State the Boolean algebra used in K-map simplification. So, in order to analyze and design the digital circuits, it is necessary to express them mathematically. In order to do so, we need to use the Boolean algebra. So, in order to express them mathematically, we use the Boolean algebra. The Boolean algebra can be defined with the help of following: a set of elements, a set of operators, a number of axioms or postulates which have not been proved yet. They are very useful in practice. A set of elements is defined as a collection of objects which have some properties common among themselves. If S is the set and A and B are the objects, then A belongs to S. This is the sign for belongs. A belongs to S, belongs, denotes that the A is a member of set S. On the other hand, B does not belong to S is an indication that B is not a member of S. A set S is specific as follows: S is equal to A, B, C, D. This shows that A, B, C, D are the members of set S. So, A, B, C, D belong to set S. Now, what is a binary operator? A binary operator is a rule which is assigned to a pair of elements form S. For example, if A dot B is equal to C, then dot is a logic operator which operates on the pair A and B to produce C. So, this is a logical operator which is logical multiplication. And this logical operator operates on A and B to produce the result, that is C. Postulates. The postulates of mathematical systems such as Boolean system are the basic assumptions from which we can derive or formulate the rules, theorems and properties of the system. The most common postulate which is used in the Boolean system are as follows. So, first is the closure, second associative law, third commutative law, fourth identity law, fifth inverse and sixth is the distributive law. So, closure. A set S is said to be closed for a particular binary operator if for every element of S, that binary operator specifies a rule to obtain a unique element of S. So, it is said to be a closed operation if the binary operator for every pair of element S, that binary operator specifies a rule to obtain a unique element of S. Second is the associative law. For a given set S, a binary operator is said to be associative if it satisfies the following condition: A into B bracket into C equal to A asterisk B into C for all. So, over here it can be A plus B plus C equal to A plus B plus C, or A into B into C equal to A into B into C. What is a commutative law? For a set S, a binary operator asterisk is said to be commutative if the following equation is satisfied: A into B equal to B into, so B asterisk A, so A into B equal to B into A, or A plus B equal to B plus A. Then it is said to be commutative. Identity. A set S is said to be having an identity element with respect to the binary operator asterisk on S if there is an element X in the set S that satisfies the following condition: X into A is equal to A into X. What the element should return? The output or the result should come A. So, A plus 0 equal to 0 plus A. What are you getting? You are getting A. So, in the place of X you have 0. In the place of X you have 0. And what is X? X is nothing but the identity element. X is the identity element. So, in case of addition, the identity element is 0. Same way, a into 1 is equal to 1 into a, output is a. So 1 is nothing but x. 1 over here is also nothing but x. X is the identity element. So in case of multiplication, identity element is 1. Inverse, a set S having an identity element x with respect to the binary operator asterisk is said to have an inverse if for every element that belongs to S there exists another element b which also belongs to S such that a into b is equal to x. So for example, in case of addition, a plus of minus a equal to 0. So this is nothing but the inverse. So inverse of addition is subtraction, because a into b should give you x. X is what? X is the identity. And we have already seen that in case of addition, my identity element was 0. So here I have to get a 0. So a minus a equal to 0. So here minus a is b, a is a, and x is 0 in case of addition. So what is the inverse of addition? Subtraction. Similarly, for multiplication, a into 1 by a is equal to 1. So 1 by a is nothing but your b, a is your a, and 1 is your identity, that is x. So 1 by a is division. So the inverse of multiplication is division, inverse of addition is subtraction. Distributive law: if asterisk and dot are two binary operators working on S, then asterisk is said to be distributive over dot if the following condition is satisfied. A asterisk b dot c is equal to a asterisk b dot b asterisk c. Next is conclusions. Field is an example of an algebraic system. It is a set of elements along with the binary operators, each of which follows the properties mentioned from 1 to 5. The logical operators jointly possess the sixth property. What was the sixth property? Sixth property was the distributive law. This is jointly possessed by the logical operators. Jointly possessed means addition and multiplication both jointly will possess the property of distribution. Two operators are involved. The field of real numbers is obtained by combining the set of real numbers and two binary operators plus and into. This field of real numbers is the basic for arithmetic and algebra. The operators are postulates of such a field having the following meaning. So what are the meaning? We define the operator plus as addition. The identity element for plus is 0. We have already seen that. We define additive inverse as subtraction, because we have already seen a plus minus a is 0. So this is nothing but the subtraction. So additive inverse is subtraction. Identity for plus is 0, because a plus 0 is equal to 0 plus a, which is equal to a. So x over here stands for 0. Next is the binary operator multiplication. Dot means multiplication is defined as multiplication. The identity element for dot is 1, because a into 1 is equal to 1 into a, which is equal to a. So your x is nothing but 1. So your identity for multiplication is 1. We define the multiplicative inverse of a as 1 by a, which is nothing but division. So a into b should give you identity. So a into 1 by a is 1, and 1 is the identity element for multiplication. The only distributive law applicable is that of multiplication over addition. That means a dot b plus c is equal to a dot b plus a dot c.